Okay. Do we have some time before the presentation, the session actually starts? Okay. So 10:30 is for setups.
Yeah.
That's a good idea.
We'll be starting it now. So, good afternoon, everyone. Now we call upon Haki Benita, the development team lead at Centra, to give away the speech of overcoming concurrence issues in web applications. If I say a little bit of his background, he is a software developer and a technical lead. He takes special interest in database, web development, software design, and performance tuning. He also writes about above in his blog, which is hakibenita.com. You can all see of his work there as well. So concurrence in web applications is so easy to get wrong and so hard to identify and debug when it comes to PyCon. We will get to know more about it from the speech. And if you have any further questions about this, kindly send us by the end of the speech and we will try our best to answer. Over to you, Haki.
Okay, thank you so much. I'm very happy to be here as well. I attended PyCon Sri Lanka last year. It was great, so I thought I'd come back again this year. I think that we have some problems with the video, but I can share my screen because the slides are what's really important. So let me just share my slides. Okay, great. Okay. So I want to talk to you today about concurrency in web applications. Okay, so you already got the introduction. I'm a software developer and technical lead. The most interesting thing about my bio is that nowadays I work primarily with open source technologies such as Linux, PostgreSQL, Python, Django, TypeScript, and so on. I really try to use almost exclusively open source technologies. So in order to talk about concurrency in web application, I thought we'd start with a very simple web application. I imagine that if you ever been through some sort of development training or even went through the process of a job interview, you most likely had to implement one of these yourselves. So our simple web application that we are going to talk about today is a URL shortener. So a URL shortener is simply a web application that provides short links like this one that redirect to very long URLs like this one, okay? Now, why would you want to do something like that? Mainly for two reasons. The first one is if you need to include links in text-constrained places, for example, SMS messages or tweets, where you are limited by the amount of characters you can actually put on the message, then this is a very long URL, and you might want to use a shorter one, okay? Another main use of URL shorteners are to keep track of the number of hits, the number of times people actually clicked the link. This is very useful if you launch a campaign, for example, and you want to keep track of how many people click the links in your email or push notification. So that's one of the main features of a URL shortener. Now, there's a lot of URL shortener out there. It's like Bitly, BookGL, Buffer LI, and I'm guessing that there's thousands of these. So we are going to build one, and we are going to use this web application to demonstrate how easy it is to make very simple mistakes when it comes to concurrency in web applications. So I'm going to demonstrate using Django and Django ORM, but none of the things I'm going to talk about is specific to Django. They're not even specific to Python, okay? I'm just using Django ORM and Python because this is what the conference is about, at least Python, not specifically Django. But if you're using Flask with SQL Alchemy or Fast API, working directly with PyCon or whatever other database that you're using, all of the concepts that we are going to talk about today apply, okay? So this is what a Django model can look like. Django model is the model that maps to a database table in Django ORM. So the name of our model is short URL, extends the Django model. And now we have three fields. The first one is the key field, okay? That's the short part at the end of the short URL. So this is a short character field, and notice that it must be unique. And the reason for that is that we're using the key to identify the long URL. So the second field is a URL field, and this is the URL that we want to redirect to. And finally, we have the hits. This is a numeric field, an integer. And this is the field that we use to keep track of the number of hits. So every time we redirect short URL to a long URL, we increment the number of hits, okay? So this is what the model looks like. So the first thing that we want to do is we want to create a short URL, okay? So the naive implementation can look something like that, okay? And that's just Python. So we have a function called create short URL, and it accepts as argument the URL that we want to redirect to and returns a short URL instance, okay? So the first thing that we do is we generate a random key, okay? We use secrets choice from a list of characters. In this case, I'm using ASCII letters and digits, and I'm generating a 5-long random string, okay? And that's my key. So now we use the ORM object short URL to create a new short URL with the key, the short URL that we received as argument, and we initialize the hit counter to 0, okay? So 90% of developers would stop here, okay? I'm guessing that you have a lot of code that looks exactly like that. You generate some random identifier and then you just save it to the database and cross your fingers that everything is going to work as expected. So most developers would stop here and say, that's fine, I'm done, and call it a day, okay? So the first mistake that I want to talk about when it comes to concurrency is failing to recognize that there is a concurrency issue. In this case, failing to recognize that there is a chance of collisions, okay? So look at the function again, but this time, what would happen if the key, the random key that we generated in the first row, the first line, already exists in the database, okay? Again, what if the random key that we generated already exists in the database? What would happen in this case? So in this case, when we try to save the object to the database, insert the row into the table in the database, we would get a unique constraint violation because we declared the key as being unique, right? So if we try to save another short URL with the same key, we are going to get an integrity error, a unique constraint violation, and this function will fail, okay? So once you realize that you have a problem where you can actually get into a situation where the random key already exists in the database, you might try to do something like that, okay? So you say, okay, so let's just iterate until we find a key that does not exist in the database. This is what it looks like. You iterate until while true, and then you generate a new key. This is exactly like before, but now, before you try to create the object, you first try to check that it doesn't already exist. This is what it looks like. Okay, so you search for any short URL with this key. And if this key exists, you iterate again and generate a new key until you find one that does not exist. You break out of the loop and create the short URL object like before. So is this okay? I mean, can we be sure that when we reach the last line in this function, that the short URL with this key doesn't already exist in the database? Okay, so that's a tough one. Take a second, take a look at the function. Okay, so let's talk about what actually concurrency means. Okay, words have meanings, and it's important and useful to know what these words mean because it can help us understand the type of problems that we need to tackle. So first, concurrent, if you look at the Merriam-Webster, which is basically the dictionary, concurrent is defined as happening at the same time, operating or occurring at the same time, okay? So far, when we looked at the functions, at the naive implementations that we suggested, we never stopped to think what would happen if more than one process is trying to execute this function at the same time. And I know it's difficult sometimes to take a step back, look at the function and ask yourselves, wait, maybe I'm not the only one executing this piece of code at the same time, okay? So now, when we understand that we might have a concurrency problem here, let's ask ourselves, what would happen if two processes execute this function at the same time? So the second mistake I want to talk about is time of check, time of use, or in short, TOCTOU, okay? So let's imagine that we now have two processes trying to create a short URL at the exact same time, okay? So now we have process one, and process one generates this random key, 86DVD, okay? And checks the database, and this key does not exist in the database, okay? Now, before process one has a chance to actually use this key to create a short URL object, process two, okay, starts to create a short URL. Now, process two happens to generate the exact same random key, 86DVD, okay? Now, when process two checks to see if this key already exists in the database, it finds that this key currently at this time does not exist in the database. So it goes on to use the key and create the object. So at this point, the object is in the database. The object that process two created is stored in the database. Now, moving back to process one, remember, process one checked the key, but before it had a chance to actually use the key to create the object, process two created the object with the same key. So now, when process one tries to use the key, we get a unique constraint violation because this key already exists in the database. Process two just created it, okay? So this is a classic TOCTOU scenario, okay? TOCTOU stands for time of